Question number 2. Find the inverse Laplace transform of 1 by s plus 2 whole square multiplied by s minus 2. We know inverse Laplace transform of 1 by s square is t. Inverse Laplace transform of 1 by s plus 2 whole square is t e power minus twice t. Inverse Laplace transform of 1 by s minus 2 is e power twice t. Let us take this function as ft and this function as gt. Now, using the convolution theorem, we will have L inverse 1 by s plus 2 whole square multiplied by s minus 2 is f star g, which is equal integration 0 to t f of u g of t minus u du. We have the function ft as t e power minus twice t, so fu equals to u e power minus twice u. 0 to t u e power minus twice u. And we have the function gt as e power twice t. So here we'll have e power twice t minus u du. Now e power twice t is independent of u, so we can take outside of the integration 0 to t u e power minus twice u, and here minus twice u, so minus 4u du. E power twice t. Now let's do the by parts. So first function is u, and e power minus 4u divided by minus 4, and it is from 0 to t. Then ddu of u is 1, so we'll have integration minus integration e power minus 4u by minus 4 du. E power twice t, putting the values of u as t, so we'll have t e power minus 4 t by minus 4, and while putting u equals to 0, we are getting the term as 0, then minus and this minus plus, and e power minus 4u by 16 minus 16 0 to t. So this is e power twice t, and t e power minus 4t by minus 4, and then minus e power minus 4t by 16, and minus minus plus e power 0 is 1 by 16. So if we take 1 by 16 common, then we'll have 1 minus 4t e power minus 4t minus e power minus 4t e power twice t. We can write by this way also, 1 by 16 e power twice t minus 4t e power twice t that is minus e power minus twice t. So this is the answer. Question number 3. We have to find the inverse Laplace transform of thrice s divided by 4 square plus 16. We know inverse Laplace transform of s by s square plus 4 square is cos 4t. Using change of scale property, inverse Laplace transform of twice s by twice s whole square plus 4 square will be half cos 4 t by 2. That is half cos twice t. Now, if we take 2/3 of inverse Laplace transform of thrice s by 4 square plus 16, then we will have half cos twice t. Because we are taking here 3 here to make it like in the question given. So 1/3 and 3 will be cancelled. The 2 will go inside. So this is equals to half cos twice t. So if we write here 2 by 3 and inside it is 3s, then it is similar to the previous line. So inverse Laplace transform of thrice s by 4s square plus 16 is 3 by 4 cos twice t. This is the answer. Question number 4. Solve d2 minus 1y equal a cos hyperbolic nt, where y at 0 equals 0, y prime at 0 equal 2. Let's start the solution. Let us take Laplace transform both sides of this equation. Then we'll have Laplace transform of y double prime minus Laplace transform of y equal a Laplace transform of cos hyperbolic nt. If we take Laplace transform of y as fs, then by the theorem that the Laplace transform on second order derivative is a square fs minus s f at 0 minus y prime 0, and here L of y, Laplace transform of y is fs. In right hand side, a multiplied by the Laplace transform of cos hyperbolic nt is s by s square minus n square. Now in the question it is given that y at 0 is 0, y prime at 0 is 2. So let us put these values in this equation. Then we'll have s square fs, this term is 0 and this term is 2, and this is fs equal a s by s square minus n square. Let us take fs common, then s square minus 1 fs is a s by s square minus n square plus 2. So fs is a s by s square minus n square s square minus 1 plus 2 by s square minus 1. Now let us find this s by s square minus n square and s square minus 1 in partial fraction. So let us take s by s square minus n square s square minus 1 as as plus b by s square minus n square plus cs plus d by s square minus 1. So s equals to as plus b multiplied by s square minus 1 plus cs plus d multiplied by s square minus n square. Now let us take s as 1. So we'll have this term as 0 and here c plus d and here s is 1. So 1 minus n square, right hand side 1. So c plus d is 1 by 1 minus n square. Now let us put s equals to minus 1. Then we'll have here minus c plus d. So minus c plus d. Rest of the terms are same, 1 by 1 minus n square. Now if we do the simplification with these two equations, then we'll have say this equation is as 1 and this equation is 2. From 1 and 2 we get minus c plus c cancel, twice d is there should be a minus sign here because s equals to minus 1, so in the left hand side there is a minus sign. So if we add them, minus c plus c cancel, twice d, and right hand side this and that term will be cancelled. So d equals to 0. And putting d 0 will have c equals to 1 by 1 minus n square. Or we can write as minus 1 by n square minus 1. Now let us take s as n. Then this part is 0 and here we will get n square minus 1 and an plus b, left hand side this is n. So we'll have n equals to an plus b and n square minus 1. So an plus b equals to n by n square minus 1. Now if we take s as minus n, then we'll have the same here, just this will be minus an plus b minus an plus b equal minus n by n square minus 1. Now say this line is 4 and this equation is 5. So from equation 4 and 5 we get, look, if we add them, an minus an will be cancelled and twice b and right hand side cancel, so b equals to 0 and um, putting b as 0 we are getting an as n by n square minus 1, n will be cancelled, so a equal 1 by n square minus 1. Now let us put all of these values here. A term and c term because b and d both of them are 0. Now we'll have s by s square minus n square and s square minus 1 which is equal as plus b by a square minus n square plus cs plus d by a square minus 1. A is 1 by n square minus 1 and this is s by a square minus n square plus c is minus 1 by n square minus 1 and d is 0. So this is s by a square minus 1. Now what is fs? Fs equals to as by, so there will be a term a and by n square minus 1 and this is s by s square minus n square and here it is minus a by n square minus 1 s by s square minus 1 and plus 2 by s square minus 1. So fs is what? Fs is Laplace transform of ft. So this is actually Laplace transform of ft. So yt. So yt is what? Yt is a by n square minus 1 inverse Laplace transform of s by s square minus n square minus a by n square minus 1 inverse Laplace transform of s by s square minus 1 plus twice inverse Laplace transform of 1 by s square minus 1. Now this is a by n square minus 1 and inverse Laplace transform of s by s square minus n square is cos hyperbolic nt by n minus a by n square minus 1 inverse Laplace transform of s by s square minus 1 is cos hyperbolic t plus twice inverse Laplace transform of 1 by s square minus 1 is sin hyperbolic t. Now we can arrange it. Yt is a by n square minus 1 taken common, then we will have cos hyperbolic nt by n minus cos hyperbolic t plus 2 sin hyperbolic t. This is the required solution. Question number 5. The center ZG of a group G is a normal subgroup of G. We know the definition of ZG, which is A belongs to G colon AG equals to GA for all G belongs to G. And we know that ZG is a subgroup of G. So for any G belongs to G and any A belongs to ZG, GAG inverse equal AGG inverse equal AE, which is equal A, and A belongs to ZG. Therefore, G belongs to G, A belongs to ZG imply GAG inverse belongs to ZG. Hence, ZG is a normal subgroup of G. Question number 6. If xz equal twice z square plus 5z plus 14 divided by z minus 1 power 4 be generating function of the sequence xn n from 0 to infinity, then find x0, x1, x2 and x3. Let's start. We can write this 2z square plus 5z plus 14 multiplied by 1 minus z power minus 4. Now we know from the expansion of this 1 minus z power minus 4 as 1 plus 4z plus 10z square plus 20z cube plus 35z to the power 4 plus so on. Now to remember this 1 minus z power minus 4, you can remember this formula 1 minus z power minus n as 1 minus nz plus n into n minus 1 by factorial 2 z square minus n into n minus 1 n minus 2 by factorial 3 z cube plus so on. So put the value of n as 4, you will get the desired series. You look that we have to find x0, x1, x2 and x3. So we will not go beyond z cube. If we get more than z cube, we will discard that. Let us first multiply with 14 because here the power of z is 0. So we will have 14 plus 14 into 4, 56z plus 14 into 10, 140 z square plus 280 z cube and we will discard rest of the terms. Next with 5z. So here plus 5z and then 20 z square and then 50 z cube and so on. Next with 2z square, so plus 2z square then 20 z cube and so on. So if we add them, then we are getting 14 plus 61 z plus 182 z square plus 338 z cube plus so on. Now if we compare with this the sequence, then we'll have here the x0 as 14, x1 as 61, x2 as 182 and x3 as 338.